In this video, we will learn a simple method to solve the last layer of the Megaminx using intuition, some basic 3x3 cube knowledge, and only a few easy algorithms. While this method is different from other beginner methods, it's intended to be easy for beginners to understand, yet also a good segue into more advanced methods. This video is a comprehensive beginner explanation of the Megaminx Last Layer and algorithms. Once you have gained a full understanding with this full tutorial, I have a shorter reference tutorial with steps only and no explanation. We will solve the last layer of the Megaminx in 4 steps. First, we orient the edges forming the gray star on top, which is equivalent to the yellow cross on a 3x3. Next, we orient the corners to get all the grays facing up, which is equivalent to all the yellows facing up on a 3x3. Then we solve the edges by placing them in the correct location relative to the centers. Last, we fix the corners, which solves the entire Megaminx. It's important to note that this tutorial is intended to help you become familiar with and understand how to solve the Megaminx on your own, not get it back to a solved state by following my every turn. This Megaminx Last Layer tutorial assumes you are familiar with notation, know how to solve a 3x3 Rubik's Cube, and how to solve the other layers of a Megaminx. If not, please watch our Rubik's 3x3 tutorial and our Megaminx beginner tutorial first. I would like to thank Gan for donating this premium magnetic Megaminx. If you would like to purchase a Megaminx or any puzzle, see the links here in the top right or down below in the video description, and also on my website, KevinGittemeier.com. Gan doesn't have a stickered Megaminx, so I purchased these budget Megaminxes to peel the stickers off to better display the pieces we are focusing on in each step. Now, a few things I would like to make clear. You will have to get familiar with and comfortable handling your puzzle. You will also have to practice, make mistakes, and fail many times before you become proficient at solving any puzzle. You will not grasp this on your first viewing and first attempt, but think of it this way. You don't have failures, you just have learning and practice opportunities. There is absolutely no reason to get upset or frustrated if you don't understand something immediately or make a mistake that scrambles your puzzle. You learn better through failures, and it gives you a practice opportunity to repeat the process to get back to that point of failure. You need practice and repetition to get good at anything, so don't get upset about another practice opportunity. Always remember this: in life, it seldom matters how fast you learn something, but rather how well you learn and understand something. This tutorial is not meant for you to follow me step by step to get your puzzle back to a solved state. There is software that can do that for you. This tutorial is to help you understand how to solve your puzzle and learn how to solve it on your own. If needed, use your pause button, slow down the playback speed, or print off the algorithms I have provided on my website, in the video description, and in the pinned comment. We start by forming the gray star on top by getting all the gray edges facing up. This is equivalent to the yellow cross on a 3x3 cube, and we use the same 3x3 line algorithm. There are only 3 possible pattern arrangements or cases for the edges, and we use the same line algorithm to solve all 3. Case 1, arrow, with 3 edges forming an arrow, which is equivalent to the line on a 3x3. Visualize these 2 edges as the line edges on a 3x3. At this point, it's important to notice that because we have 5 sides on the Megaminx, we will always have one more edge piece than the 3x3. So we position that extra edge piece where we can disregard it because it won't be affected when using 3x3 algorithms. We will talk more about this later. These 2 edges form the line. We disregard this edge and we flip these 2 edge pieces up just like on a 3x3. Case 2, 1209, with 3 edges at 12, 0, and 9, which is equivalent to 12, 9 on a 3x3. We disregard this edge piece. These 2 form 12 o'clock, 9 o'clock, and we need to flip these two adjacent edge pieces up. This position we call 0 o'clock because it's the extra fifth piece and we disregard it. Our Megaminx clock is a little skewed. Case 3, 0. One edge at 0 o'clock, which is equivalent to dot on a 3x3. We disregard this edge piece at 0 o'clock and we have 4 edges that need to be flipped up, just like dot on a 3x3. Notice there will always be at least one edge piece flipped up. If not, you have a twisted edge or a changed sticker. So we will either have 1, 3, or all 5 edges facing up. Again, if you haven't seen our 3x3 beginner tutorial, please watch it first. It will make learning and understanding this much easier. To solve the arrow case, position the top so the edges form a horizontal line as on the 3x3 cube. Disregard any gray corner pieces. We are only looking at the gray edges. There are only 2 ways to position the arrow so that 2 of the 3 edges form a horizontal line. This forms a horizontal line with the arrow pointing to the right. This does not form a horizontal line. This does with the arrow pointing to the left. This does not. This does not. And now we are back to the horizontal line with the arrow pointing to the right. With the arrow pointing to the right, perform the 3x3 line algorithm. Front, right, up. Right prime, up prime, front prime, which will orient all the gray pieces up, forming the gray star. Again, disregard any corners. We are only looking at the edges that form the gray star. So this is a solved gray star, same as this. Now if you mistakenly hold the arrow pointing to the left and perform the algorithm, it just repeats the same left arrow pattern, giving you an extra practice opportunity. Just turn it correctly pointing to the right and perform the algorithm again. If you have case 2, 1209, position the top so that the 3 edges most closely represent what would be 12 o'clock and 9 o'clock positions on a clock, as we learned in our 3x3 tutorial. So this most closely represents 12 o'clock, 9 o'clock. This clearly doesn't. Neither does this, or this. So now we are back to 12-9, or what we call 12 o'clock, 0 o'clock, and 9 o'clock on our Megaminx clock. Again, we call this position 0 o'clock because this is the extra 5th edge piece that we disregard with our 3x3 algorithms because it won't be affected. Now we perform the line algorithm, front, right, up, right prime, up prime, front prime, which makes the arrow case. Now we perform the algorithm again to complete the gray star. So with 1209, we do the algorithm once to make the arrow, then again to complete the gray star. If we happen to hold it wrong, we just get some more practice opportunities to get really good at this algorithm. If you have case 3 with only one edge, we can position it in any of 3 locations, but it's best to position it here at 0 o'clock because when we perform the line algorithm, it gives us the arrow case, so we only have to turn the top and perform it one more time. We can also position the single edge piece here at 9 o'clock and perform the algorithm, but it gives us the 1209 case, which means we will have to perform the algorithm 2 more times for a total of 3 rather than 2. Same if we hold it here at 3 o'clock. Now if you're observant, you may have noticed that the 3 locations we can put the single edge piece are also the 3 locations that form the arrow pointing to the right. If we place the single edge in one of the other 2 non-arrow positions, like here at 6 o'clock, the pattern just repeats, putting the 12 o'clock gray edge in its place. If we put it here at 12 o'clock, it flips this 6 o'clock edge to 3 o'clock. Before proceeding, pause the video and just play around with this for a few minutes. You will quickly gain a full understanding of all the positions while simultaneously practicing the algorithm. In part 2, intermediate method, we will learn the reverse of this algorithm and others. But as a beginner, just use this one algorithm, at least for the first few days. Don't try to learn too many algorithms in one day, because the more you learn at one time, the less you actually understand what you learned. It's preferable to learn and understand it rather than memorize it. Next, we want to orient or flip all these corners so that the gray side is facing up. The beginner 3x3 method to do this is to use a 4-move sequence over and over again to cycle the corner orientation. I'll demonstrate on this 3x3 demo cube first. We need to flip or orient these 2 yellows up to solve the top face. So we start with a corner that we need to flip on the right side here and perform the algorithm R prime, D prime, RD, R prime, D prime, RD repeatedly until the yellow's facing up. Now as you can see here, it scrambles this down here, but that will resolve itself when we solve the last corner. So now we move the next corner that needs to be flipped right here in its place. Make sure not to turn the cube in your hand, just turn the top and perform that same sequence. R prime, D prime, RD, R prime, D prime, RD, R prime, D prime, RD. Or you can think of it as down, down, up, up. And once that last one gets flipped, the scrambled portion resolves itself. Just make sure to turn the top and not the cube in your hand. I never actually taught or use this method on the 3x3 because it's inefficient. There's a lot of potential for mistake, and we can solve all 7 3x3 patterns or cases with only 2 algorithms. But on the Megaminx, there are 16 possible cases, so we utilize the beginner method corner orientation. So just like on the 3x3, we start with the corner that we want to flip or orient right here on the right side, and then we perform the algorithm R prime, D prime, RD, R prime, D prime, RD, until the gray's flipped up. Then again, turn the top so that the next corner we want to flip is in the same location. Don't rotate the whole Megaminx in your hand. R prime, D prime, RD, R prime, D prime, RD. Now for the last one, you can also think of this as down, down, up, up, down, down, up, up. And then once the last one is flipped, this will resolve itself. If you've done everything correctly, once you flip the last gray corner, the scrambled part will have resolved itself. Notice that if the gray is facing you on the right, you only have to do the sequence 2 times. But if it's facing you to the front, you'll have to do it 4 times. And again, the scrambled portion at the bottom has resolved itself. Here is a practice strategy. Perform the 4-sequence algorithm while saying down, down, up, up, down, down, up, up, down, down, up, up, or 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. Remember, always 4 turns, no less. Pause the video and do that a few times. Once you have the gray facing up, make sure not to forget this last turn, whether you call it D or up, because the bottom scramble won't resolve itself once you flip the last gray corner. So for example, here I forget D, then after I flip the last corner, this is still scrambled and I get to practice some more. If we have several or all corners to flip, this can be time consuming and is inefficient. But fortunately, we have a cheat code to get all the grays on top. Up, up, down, down, left, right, BA start. We can use some of the 3x3 algorithms that we learned in our 3x3 tutorial to get more or even all of the grays facing up. We will use a few simple ones like little fish and big fish, but it's important to know that because the Megaminx has 5 sides, U2 is not equal to U prime 2 like it is on a 3x3. So watch each of these corners on the right with the blue facing up. U2, U prime 2, U2. So as you can see on the Megaminx, they're not in the same location because of the 5 sides. Yet on the 3x3, they are. U2 is equal to U prime 2 on a 3x3, not a Megaminx. So you may have to adapt your algorithms just a little bit. Here, the little fish algorithm flips all the grays up. Here, big fish flips all the grays up. And here is an example where we use little fish to get more of the grays up. So now we only have to flip these two with beginner method. And that's much easier than doing them all with beginner method. There are 16 possible corner orientation cases, each with its own algorithm. But in our intermediate tutorial, we will learn how to solve all 16 using only a few algorithms: forward, backward, and mirrored. Once you're able to solve the Megaminx and familiar with it, it really is much easier than it would seem to solve all 16 cases. So again, when doing beginner method, once you get the gray flipped up, don't forget to flip this back, because if you do and you leave it down here, you're going to get another practice opportunity once your grays are all up. If you do have this problem though, don't start from scratch. Just look over and see what it's going to take to solve this. Just build this back up, start to build that up, and then that, and then go back to your top. Now that we have all these grays facing up, we need to permute these edges to match their corresponding centers. We need to solve the edges. There are 3 possible cases, but we will use just one algorithm to solve them all. Case 1, 2 edges solved at 12 o'clock and 6 o'clock. Case 2, 2 adjacent edges solved. And case 3, only 1 edge solved. Step 3, case 1. What we are looking for is 2 correctly positioned or solved edges at 12 o'clock and 6 o'clock. We're going to use one simple algorithm to shuffle these other 3 edges counterclockwise. Coincidentally, the 3 arrow edges. Now if we look at the side color of these edges, we can see that this one needs to move counterclockwise here to match its center. This one needs to move here, and this last one needs to move here, which will solve all the edges. So now I'm going to do an easy algorithm to shuffle the 3 edges counterclockwise. I'll try to do this slow at first. And now the edges are correctly permuted or solved. Okay, one more time, but a little bit slower. Now again, but a little bit faster this time. Now there are 2 ways to learn this algorithm. Memory with repetition, which is easy, or look at it and understand it, which is also easy. Here's our 2 solved edges at 12 o'clock, 6 o'clock, and I've marked these so we can track and follow them. If we look at this edge piece, I turn the side twice to hide it. We can hide it here or here, but I choose here. Then we move this 3-piece section clear out of the way with a U2, which also brings the edge that we want to replace right here. We don't just turn the top once, because then the edge we want won't be over here, and when we come back with the side it breaks up our 3-piece, and that's not right. So just remember, we need to preserve this 3-piece block at all times. So from the beginning, to move this piece here, we hide this one, move this over here, and then when we bring it back, those 2 traded places. Move this around, trade that one, and now all 3 have traded places. An easy way to remember this is just watch your 3-piece section on top. Move it all the way around and back in. Without breaking it up. If we do the wrong number of turns, when we turn the side, it breaks it up. The side is easy to remember because you're just going back and forth, pulling the grays down and back up. So just watch your 3-piece and don't spill your soda. Pause the video now and do this algorithm 6 times. Slow at first and then increasingly faster. Now if you line these 2 edges up here correctly at 12 o'clock, 6 o'clock, and this piece does not need to move counterclockwise, and these 3 all need to move clockwise to correct themselves, just turn the top U2, then these 2 will be lined up at 12:6, and this will fix when you move counterclockwise. Pink counterclockwise here will fix, beige here, orange here. So again, if these are lined up, if this does not need to move counterclockwise and it needs to move clockwise, then just turn the top twice, and when you line these up, then a counterclockwise rotation will fix them. Alternatively, you can just do the algorithm twice if you like. And that will fix them. And in our intermediate method video, we'll learn the reverse algorithm to shuffle them clockwise. But for now, as a beginner, just use the one counterclockwise algorithm. If you have two adjacent edges solved, you won't have a pair of 12 o'clock, 6 o'clock edges solved. So what we need to do is turn the top. Notice two other edges are solved. So we turn the top and notice that two other edges are solved. Now we look for the color that doesn't match either way. So here these two edges are solved. Here these two edges are solved. So this beige never gets solved. So we turn it to match its center color and place that to the front. Now we do the algorithm once. And at this point we have a 12 o'clock, 6 o'clock. And we can see if we do it again, a clockwise rotation here solves the edges. So again, these two edges are solved. If we turn the top, these two edges are solved. So we take the odd color out, match it to its center, and perform the algorithm once. At this point, we have a 12 o'clock, 6 o'clock. We can see a counterclockwise rotation solves all of these. So we perform the algorithm again, which solves all the edges. So again, these two match. When I turn the top, these two match. This is the odd one out that never matches. We move it to the front, matching its center color. We place this on the front, and then we notice a counterclockwise rotation here will place the green here, giving us a 12-6. We match this to its center color, hold it to the front, and perform the algorithm. Now we have these two. We hold it where they're at 12-6, and we can see now one more rotation counterclockwise will solve all the edges. If only one edge will line up at a time, just put any solved edge to the front and perform the algorithm. You will then have case 2, two adjacent edges solved. Turn the top until you get just one edge lined up with its center. Place it to the front and perform the algorithm again to get the 12 o'clock, 6 o'clock case. Then one final time to solve all the edges. You won't get just one edge very often though, but when you do, it will just be good practice to perform the algorithm and get familiar with all the cases. If only one edge will line up at a time, just put any solved edge to the front and perform the algorithm. Then you will have two adjacent edges solved. Turn the top till you just get one edge lined up with its center. Place to the front and perform the algorithm again to get 12 o'clock, 6 o'clock case. Then one final time to solve all the edges. Now we just need to permute or move the corners in the correct location, which will solve the entire Megaminx. You will either have 3 corners incorrect, 4 corners, or all 5 corners incorrect. Never 2, and obviously never just 1. If you have 1 corner incorrect, just twist it correctly. We will use a 3x3 beginner technique to reposition these corners. We start with any unsolved corner here to the right. Notice the color. It's a orange green, and it needs to go here between the orange and green edges. So what we'll do is we'll take this and hide it down here, move this top back up. So now we have all our grays here, but we've just removed and hidden this orange green. Since it needs to go here between these two edges, we pull that over here. Since it needs to go here between the orange and green edges, we just move the top, positioning this here, pull this one down, and now we'll insert the gray in its place. So now what we've done is inserted the orange green corner up here, but then hidden this one down here. This is a green pink, which needs to go between these two. So we do the same thing. We turn this down. We'll replace this with the green pink. When we move that back up, it's in the correct position. Notice this seems to scramble this down here, but when we fix the last corner, it will resolve itself. That's where the math comes in again. So now this has to go there. We'll pull this down, insert this corner, and move it back. Now when doing this, don't think about or copy notation. Just look at the gray corner pieces and insert them logically. Now to fix these corners, we're going to use a 3x3 beginner method to reposition them. So what we're going to do is start with any unsolved corner right here on the right. We'll remove this corner and hide it down here. Replace the grays back to the top. So now we've got our top, but we've just moved and hidden this green and pink corner. It needs to go here between the green and pink edges. So what we'll do is move that top over here. We'll take this gray out by inserting this one in its place. Now it's correct relative to the edges, the green and pink edges. Now we notice the color right here, which is blue and beige, which needs to go between the blue and beige edges. So we move the top, pull this down. We'll remove this by replacing it with the blue and beige. Move this back to the top. Notice this scrambles this, but that's where the math comes again. Once we solve the last corner, it will resolve all of this. Move the top. Here's the last one. Pull it down. Insert this gray. And when you move it back up, not only are all the corners fixed, but you've resolved what you've scrambled down here. Be sure not to confuse this 3-move sequence with the 4-move sequence we use to flip the grays up. When doing this move, don't get hung up on notation. Just look at the gray pieces and insert them logically. There is a scenario to be aware of, the 4-corner even number scenario. If you have 4 corners to fix, which is an even number, once you fix 2, you will have 2 more to fix, but they will both be on top still with neither gray corner pulled down and hidden. In this scenario, just turn the top so that an unsolved corner rests above here, then pull the corner down here to hide it. But when you hide the corner, be sure to turn the side so that it solves itself more rather than mess up further. So if we turn it this way, it scrambles further and puts the bottom whites up here. So what we want to do is turn it this way to hide the gray corner while fixing this block. Then turn the grays back to the top. You don't need to memorize anything here, just look at it and turn it in a way that solves it further. Now we notice the colors of this corner that we've just pulled out. Turn the top so that this corner's home is right above, then we insert the corner. Now for the last corner, we just turn the top and insert the last corner, which will fix this section we scrambled and the top layer. So again, if at any time you don't have a hidden gray down here, we will just look on top and find another unsolved corner. Turn the top to position it here on the right. Be sure to turn the top and don't just rotate the cube in your hand, because the scrambled portion won't resolve itself and you'll create a practice opportunity. Now pull this corner out and insert it into the correct position, then solve the last corner. So now if I do it wrong, now while first learning and practicing this, you will make mistakes and mess up this section. Don't sweat the small stuff. You will gain a better understanding with success combined with failures than you ever will with success alone. Okay, so here's one with just 3 wrong. This corner goes here. This corner goes here. And the last corner goes here. All the even number ones are pretty obvious. The only one that's a little tricky is the 4 corner. So all 5 of these are wrong. We'll just start right here, pink and beige, which needs to go here. That one's fixed. Now we have orange blue, which goes here. Blue beige, green pink, and green orange. Last one. Pretty straightforward. The only one tricky is the 4. So we'll try to do that again. Okay, again here we just have 4 wrong. So when these two trade, these two will still need to be fixed. So now that one will go over here. So now those two are solved, but we've got all our grays on top and this is still scrambled. So what we have to do is just move the top over. Remember, don't twist this Megaminx in your hand. Just turn the top, because that's what's going to resolve all this. Now we pull this one out. It needs to go right here. Oh, I just messed up actually. So I just, that's an important note. When you pull this out, make sure you turn it in a way that further solves this. So you can just kind of look at it intuitively. If you turn it where your whites are up here, that's definitely wrong. So that's the one trick that can catch you. You have to know which way to turn it, but just turn it in a way that fixes the Megaminx more. Now this green orange needs to go here. So that's the only little trick to that. Other than that, the corners are real easy. You actually won't have 4 that often. A lot of times it's 3 or 5. And again, you'll never have 1. If you start seeing goofy stuff like 1 corner or 1 edge, then you've got either a sticker removed if it's a stickered Megaminx, or you've just got a twisted piece. Little fish mirror, big fish mirror, double little fish, double big fish, triple fish,